Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. The topic is transformer. We use electrical energy at our homes. This energy is provided by the power stations, which are far away from our homes. This electrical energy is transmitted from power station to our homes through transmission lines. Due to resistance of the lines, some of energy wastes as a heat energy. To overcome this power loss or line losses, the energy is transmitted at high voltage, and that high voltage is not suitable for use at homes. Therefore, when this energy reaches in the town, again its voltage is decreased. For this purpose, a device is used, and that is called a transformer. Our today's topic is this transformer. It is a device that is used to step up or step down the applied alternating voltage. Remember that transformer is used in alternating quantities, alternating current and alternating voltage in AC circuits, not in DC current. On what principle of physics a transformer works? We know that when current is changing in a coil, there produces current in a nearby lying another coil. This phenomena is called mutual induction. So, transformer works on the principle of mutual induction, means changing current in one coil produces current in a nearby lying coil. What are the different parts, or what is the construction of a transformer? A transformer consists of a hard iron core that is not made from a single lump of iron, but it is a rectangular solid frame made by compressing the sheets of iron such that there is a layer of insulating material like paint between each two sheets. These sheets are pressed together to form a rectangular solid frame that is called laminated iron core. This technique increases the magnetic field in the core. There are two coils wounded on this frame. One is called primary coil, across which we apply the voltage that is to be stepped up or stepped down. Another is called secondary coil, across which the output is taken. So, a transformer consists of three parts: a laminated iron core, a primary coil, and a secondary coil. How it works? Students, when alternating voltage is applied across the primary coil, this produces a changing magnetic field in the core of the transformer, and this changing magnetic field is linked with the secondary coil. So, in the secondary coil, magnetic field changes with the time, and this changing magnetic field produces EMF in the secondary coil. By this way, due to phenomena of mutual induction, a changing current in the primary coil produces current in the secondary coil. Now, transformer's equation. If Vp is the voltage applied across the primary, Vs is the voltage across the secondary, Np is the number of turns of the primary coil, Ns is the number of turns of the secondary coil, then according to transformer equation, ratio of the voltage across the secondary to the primary is equal to the ratio of number of turns of secondary to the primary, means the ratio of voltages is equal to the corresponding ratio of number of turns. It is called transformer's equation. In numericals related to transformer, three of these values will be provided and any fourth can be asked. So this equation can be rearranged according to the situation of the numerical. However, it is the equation that we call equation of transformer or transformer's equation. Now students, transformers are of two types. One is called step-up transformer. Look at this diagram. In this transformer, the number of coils in the secondary are more than the number of coils in the primary. Such type of transformer is called step-up transformer, in which number of turns of the secondary are more than the number of turns in the primary. This type of transformer increases the applied voltage at the output, and they are used at power stations to step up the generated electrical power. Next type of transformers are step-down transformer. In a step-down transformer, the number of turns in the primary are more than the number of turns in the secondary. Number of turns in the primary are greater than the number of turns in the secondary. This transformer decreases the applied voltage at the output. These type of transformers we use at our homes or in our towns to step down the supplied voltage from the company, or in our electrical appliances like TV, like computer, like our mobile phone. When we are charging a phone, our charger is actually a step down transformer that decreases 220 volts supplied by the company to 6 or 9 volt required for the charging of a mobile. So these are two types of transformer, step up and step down. Student, this is all about transformer. I hope it is clear. Students, thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.